All right, folks, welcome to another edition of Tiny Talks, wherein Rocket alums share some insights from the real world use cases that they have worked on. Today, we have Balaji from GeekyAnts, who's going to walk us through how do you send messages in bulk. So, like, this is a pretty common use case wherein you want to send out uh, either promotional marketing messages via email or SMS to a lot of your potential customers. And how do you do that in a way that is scalable? If you want to schedule it at a particular time, so all of that uh, we'll see how to go about that. All right, over to you, Balaji.
Yeah, thank you. So good morning, everyone. I'm Balaji. I'm currently working as a backend developer at GeekyAnts. And today, let's see how we can implement a system that can send thousands of marketing or promotional emails and SMS using BullMQ. So let me share my screen. Just a second. Is my screen visible?
Yes.
Okay. So before talking about BullMQ, first we need to understand what message queues are, because at the end of the day, BullMQ is nothing but a message queue with additional functionalities. So in simple terms, message queues are nothing but normal queue, which has a queue of messages. And it works on the FIFO principle. That is, the message which is being enqueued first, or rather pushed into the queue first, would be dequeued and processed first. So there are few other components which we need to understand around the message queues. The first one is the producer. So producer is the one which produces, or rather pushes the message into the queue. And we have the consumer. So consumer is also called as a worker. So this is the one which pulls these messages from the queue, processes the message in the queue. So here, let's consider an example. So our producer has produced around 4 messages, and now the consumer will pick up the message 1, processes it. Again, next it picks up the message 2, processes that, and once it's being processed, it will be removed from the queue. And 3 and 4. So the order in which the messages are being processed is same as the order in which they are pushed into the queue. So let's consider an example here. So in this example, first, now the consumer checks the queue and it sees the message 1. So it processes it. If the processing is successful, this would be removed from the queue. Similarly, it picks up 2, processes this, and then it removes from the queue. Now let's consider an example that while processing this message 3, an error occurred. So as soon as the error occurred, our consumer shuts down, and then after some time it restarts. So and the next time when it checks the queue, it sees that there is message 4. Now again it processes this message. If it's successfully processed, it would be removed from the queue. Do you see a problem here? So our message 3 is neither processed successfully nor it is present in the queue. So we can consider this as the message is being lost. And this is not a good scenario because now our system is not consistent. So we cannot expect that consistency. So how do we solve this? One approach which we can suggest is that, let's assume the same example that the messages 1 and 2 have been processed successfully. Now while processing the message 3, the worker encountered an error. And now as soon as this message is, while processing, if an error occurs, the worker pushes the same message back to the queue. And now it sees the queue and it has the message 4, it processes this, and then it's being removed from the queue. And again, now the worker retries to process this message 3. If this is being processed successfully, well and good. All our messages have been processed, but only difference is the order would be changed. Now it is 1, 2, 4, and 3. That is fine. But another issue is, what if this message itself is corrupted? So again, the second time when the worker tries to process this message, it would again encounter an error because the message itself is corrupted. So again, it pushes back to the queue, and this forms an infinite loop. So let's assume we are using any of the message queue services like SQS from Amazon or BullMQ or even RabbitMQ. Our cloud bills would be skyrocketed. So even this is a better approach than the previous one, but still this has disadvantages. So how do we solve this infinite loop problem? So the next approach would be, again, considering the same example, our worker processes these two messages successfully. And now this time when it encounters an error while processing the message 3, instead of pushing this message back to the same queue, now the worker pushes this message to a separate queue called error queue. Technically, it is called as dead letter queue. And we also have a separate worker which processes the message from this dead letter queue. So the responsibility of this worker is only to process the messages in the error queue. So again, now the worker sees this message 4, it processes it and pulls it out from the queue. Now this error queue worker uh, tries to process this message 3, and if it's being processed successfully, well and good, all our messages are processed successfully. Now let's assume this error queue worker also encountered the error while processing the message 3. Then it discards this message. So you see the advantage of this approach. So it's like we are at least trying to process a message twice before it is being discarded. So this is the ideal approach, and we can also specify how many times an error message can be retried. So as of here, I've just shown one retry. Actually, we can configure this using BullMQ. So this is a basic concept of message queues and internally how this is how the BullMQ works. So now coming to BullMQ. So how do we actually implement all these things? So generally in production level applications, we do not write all these things from scratch. Rather, we use libraries which does the same job for us. And one such library is BullMQ. So BullMQ is a Node.js library that implements a fast and robust queue system, which is built on top of Redis. This is important, on top of Redis. So what is Redis? So Redis is basically an in-memory data store, which can be either used as a database, a cache, a streaming engine, or a message queue or a message broker. So in this scenario, we are using Redis as the message queue. Okay, so this is the top level diagram of what we're going to code now. So this is our node server. Let's assume we have two services, the marketing service and the email service. So this is the actual place where we have the logic to send out emails to the users. So the what does this marketing service do? So basically, it initializes a queue, and we have named this queue as email queue, and we have also named the worker in the email service as email queue, so that now Redis knows that this is the worker for this particular queue. So we push the messages. What does this message contain? We also call this message in the queue as a job. So it basically contains the data which is required by the email service to send out the emails. So basically that would be the email ID, subject, and the body. So marketing service pushes a job, or rather a message, which contains the payload which is required by the email service to send out the actual emails. So it pushes all the data, and here is where our BullMQ is. So basically Redis stores the state of the BullMQ, and this worker will pull these messages from the Redis and sends out the message. So let's see how we can implement this. So I have two files, producer and worker. So you can consider this producer is in the marketing service, and this worker is in the email service. So as you see, I have installed BullMQ, and I have created a queue, and I have named this queue as email queue. You have to give the same name to the worker so that Redis knows that this is the worker for that particular queue. So I have given the same name here. And coming back to this one, as of now, I have only pushed one job, rather one message, and we can give any name to a particular job. So, and I have passed the payload, which is required by the worker to send out the email. So this is the email, subject, and body. And coming to the worker, so here I have basically we have destructured those things, the jobs payload here, and I've logged few things so that we get to know when this particular worker has started processing the job. And I have used a simple send email function just to mimic the asynchronous functionality. Let's assume it takes around 5 seconds to send an email. So I've just resolved the promise after 5 seconds here, just to mimic the asynchronous behavior. And just to know the status of the job, whether it's completed successfully or it's failed, BullMQ provides us few listeners which we can attach to the worker. So let's assume this function resolve the promise, basically, which is a success. So these things would be logged, and whenever it fails, these things would be logged. So let's just try one example. So this is my producer and this is my worker. So I'll just add one email. Before that, let me start my worker as well. Okay, let me add another job. Okay, so here the job with ID 5 was added to the queue, and you see immediately the worker has pulled that job and it started processing. And after 5 seconds, it's giving that the email was sent successfully. So since we have not added any delay, it started processing immediately. Now let's see, let's add some delay and see how the behavior is. So in the producer, I can also pass a delay here. So just for an example, I'm going to add a delay of 5 seconds. So basically we need to pass the delay in milliseconds. So now you can see that the job would be processed by the worker after 5 seconds. So let me add another job to the queue. So now you see immediately the logs are not coming. After 5 seconds, our worker starts processing the job. See, after 5 seconds, we got this. And again, after 5 seconds, it gives the message saying that it's being sent successfully. So can you see one use case here because of the delay? Now we can schedule when we want to send a particular email. So let's assume I want to send this particular email to this user on 10th of October at 10:30. So I have to just calculate the delay in milliseconds from the current time when I'm pushing that particular job to the queue till this date. So I can specify this delay. So now the message would be sent at that particular time. So this is how we can schedule when we can send a particular email or SMS to the user. And talking about the retries. So before that, now we'll do one thing. Instead of resolving the promise, I will reject the promise with an error saying that an error occurred while sending the email. So this is a scenario where while the worker was processing the job, it encountered some error. So now we should get this particular log. Let's see if we are getting that or not. Before that, I'll just restart my worker. Now I will add another job to the queue. So you see, okay, we still have the delay, so it will take 5 seconds to process. So after 5 seconds, our job has started processing. And again, after 5 seconds, see, it gave the failed error message. An error occurred while sending the email. Since we have not specified the number of retries, by default, it's going to process our job only once. If it has failed, it'll discard it. So now let's see how we can add this retry. So in the producer, we have another key called attempts. So if I add this attempts as 3, now our worker will retry the same job thrice before it is getting discarded. So let's see if that's happening or not. So again, I'll push a job, and then after 5 seconds, it will start processing. You see, this is the first try, and immediately after that, it is going to retry again. So this is the second try. After 5 seconds, it will fail. And again, now this is the third time. This is the last retry that happens. And after 3 times, now it will discard that message. So this is how you can retry. So internally, the dead letter queue concept, that's how it's working. And coming back to this, let's assume we have to send, just for the statistics, let's assume we have to send 1,000 emails. So now we are only adding the payload of one user in each job. So if we want to send 1,000 emails, 1,000 different jobs would be created, and our queue would be overwhelmed because it has a lot of jobs, and even our worker sees that it has 1,000 jobs which it needs to process. So ideal approach is to send emails in batches. So let's see how we can send this in batches. So just for example, I've considered an array of 10 users. So just for the implementation, but let's assume this is 1,000 users, and ideal batch size would be 100 people. So there would be 10 jobs to send out the email to 1,000 users. So now our worker picks one job at a time, sends an email to 100 users. Next, it picks up the other one, and then it starts sending emails via 10 different jobs. But just for example, I've considered only 10 users and the batch size is 5. So totally we'll be having 2 jobs now. So let's see how this works. So just a second. I have started the consumer. Now let me just a second. So I have a different producer for the batch emails. Okay. So you see here. So this particular, there are 2 jobs. So first 5 users were sent in the first job. So worker 1 completed this. And here you can see the second one. The next 5 users were sent in the second job. So the mails were, actually the job was divided. Now let's assume again there are 1,000 users and now we have 10 jobs. If we have only one worker, let's assume, we have given the timeout of 5 seconds. So it would take 5 seconds to send email to one user. And if we have only one worker, so each job has 100 emails. So 100 into 5, so that is 500 seconds. Each job takes 500 seconds and we have 10 jobs. So it would take 5,000 seconds, assuming everything goes fine without any retries, all those things, for our worker to send out email to 1,000 people. So is there any way where we can improve this? So this is where the scalability comes. We can spin up more workers. So let's see how we can do that. So if you see here, I had previously commented this. So I'm spinning up one worker. Now we have 2 jobs in this particular example. So each worker would start executing one job. So we can spin up as many workers as we want, depending on the number of emails that we are sending on. Also, the importance of that email, if that has to be sent immediately, will spin up even more workers. So now we have 2 workers. Now let's see how the task is getting divided between the workers. So before that, let me restart this. And now again, 2 batches would, 2 jobs would be added. And if you see this carefully now, just a second, I'm not able to see this. Yeah, if you see this here, worker 1 has taken one job where it has sent email to 5 users, and worker 2 hasn't. So it's like, this is like parallel, concurrent processing, I would say. So this is how you spin up more workers depending on the use case. So yeah, this was all what I wanted to explain about BullMQ. So there are a lot of other features, other functionalities which BullMQ provides us. You can go through their docs. It's like really nice. There are a lot of other features. For example, while retrying, we can also specify the backup strategy. Like we can also add delay before it retries. And there is something called type as exponential and fixed. So if we give this type as exponential and delay as 1 second, so for each and every retry, the time increases exponentially. So in this case, whenever it's retrying to send the email for the second time, so the delay would be 1 second. The next time it would be 2 seconds. The next attempt it would be 4, 8, then 32 seconds. So there are a lot of other stuff which we can implement using this BullMQ. So I just covered the basics of this. You can definitely go through this talks. It's like beautiful. You can implement a lot of stuff using this. So yeah, that's all I wanted to share with you guys regarding BullMQ. Any questions? Hello?
Yes. Folks, if you have any question, you can either type or raise your hand.
I see one question, reduce the time to 1 second by Mayur Chawla. Can you please explain what exactly it is? Sorry, I did not get your question. No, it's not. Okay.
All right. I think we can do a quick reflection because that will help us know uh, what kind of learnings we had from this session. So folks, will take 30 seconds. Um, whatever yours was your uh, one key takeaway, just type in the chat. Don't press enter yet. Um, and
For
let's do that reflection.
newsletter subscription, can use BullMQ. Can you please elaborate more on this question? I think Bairagi has a question for newsletter subscription, can we use BullMQ?
Sindhu, can you unmute and elaborate?
Like weekly email update. So you mean to say whenever your newsletter is out, you have to send an email saying that we have published our newsletter for this week? Yeah, definitely. You can use this, like you in your DB, you know who all, or like what are the users who have been subscribed to this particular newsletter, and definitely you can schedule a mail. If you know that you're going to publish your newsletter on Sunday, let's assume, I mean today Sunday, maybe tomorrow, so you can definitely schedule by giving that delay, and you can pick those users email, and basically you can send an email saying that our newsletter has been published. Definitely you can. And one more important use case where we can use is like in push notifications. In push notifications as well, people intensively use this BullMQ. I see another question from Omkar. Are you ever bottlenecked from email SMS service? Is the backoff used for that? Can this dynamically generate new workers based on counts? Good question. Uh, Dynamically, yes, we can spin up workers because we know the batch size. So depending on the batch size, we can write a logic. Let's assume in the example which I explained, so there were 1,000 users. So I definitely know the batch size. I have decided the batch size, and I know there are 10 jobs, there would be 10 jobs. So based on that, I can spin up 10 workers. I can write a code to dynamically spin up the workers. Definitely. Yes, we can do that. So now all the 10 jobs would be processed concurrently. Yes. And one more thing, we have to make sure that the number of workers is either less than or equal to the number of jobs we have in the queue. Else it would be waste of resources. Let's assume we have 10 jobs and we have spent up 15 workers. So those 5 workers would be of waste. They don't have any jobs because already the 10 jobs would be assigned to 10 different workers. So that's one thing which we have to be careful of. Can you point to some differences between Kafka, BullMQ, or are they same? See, it's like I would say Kafka can be configured as a BullMQ. See, Kafka is basically used for subscriptions. See, in this one, each job would be sent only to one worker, but in Kafka, you can send the same job to different workers. In BullMQ, I can never send a job to all the workers which I have spent up. That is not possible. But in Kafka, that is possible. The same message can be consumed by all of my workers. But in BullMQ, that is not possible. That's the major difference. Okay. I think Puneet, did your question get answered? Yeah. Thank you.
All right, let's do that reflection complete now. So your one key takeaway from this session, type into the chat and let's see those takeaways in 5, 4, 3, 2, 1. Press enter now. All right, I see some messages incoming.
Yeah, so Omkar,
Automate the
learning to use libraries greater than yes, especially when we are uh, doing some production level applications. Yes, we can do it from scratch if there is no such library which satisfies our exact requirement. That's the only case. Else, all these things are auto scalable. We need not worry about scaling all these things and retries. Everything is already built. We just need to know how to use them. Right. Yes, best for automation for notification subscription. Correct.
awesome. So I think we have I think this was a pretty well structured talk. This was like all the examples and everything were very visual, and uh, it really seems like you have researched well into this. So yeah, I think that was pretty neat, and I'm sure this would be one of the most rewatched recordings because of the types of examples used. So yeah, I think
Yeah,
this
thank you.
is pretty great. All right, folks. So with that, we have come to the end, and like yeah, again the responses keep on coming. Um, Good session, good insights, best for automation, worth the time. Intro was really good, easy to use, reduces a lot of code. Live code snippets and console was fun. Yeah, I think as developers, we really get excited by seeing things in action rather than theory. So yeah, both that as well as how you started, which is a visual approach of messages and the producer consumer. I think yeah, that was also super awesome. All right, with that, we have come to the end of today's Tiny Talk. Um, Folks, if anyone wants to uh, or is considering giving a tiny talk in like any time later this month, you can sort of stay back and we can discuss what topics we can uh, uh, keep. And yeah, for others, yeah, I think we can end this session and see you folks next time. All right, have a good Sunday. Bye bye.
Thank you. Bye.